All right, guys, back at it. And we are going back to some topics in trigonometry these last 2 weeks. Okay, so one of the topics we want to take a look at this week is using what's called the law of sines and the law of cosines. Okay, we use these to solve triangles that are not right triangles. Okay, so we're going to primarily just be concerned with the law of sines today and tomorrow, and then we'll look at the law of cosines later on this week. Okay, so the law of sines, and this happens in any triangle at all. If you take the sine of an angle and put it over the length of the side opposite, okay, so we'd have the sine of angle A over this little a, which is side BC. Those three ratios have to be the same in any triangle. So we would get the sine of angle B over the length of the side opposite that, so sine of angle B over this little b, and then the sine of angle C over the length of the side opposite this little c. And in any triangle, okay, these three ratios have to be the same. Okay, so we can use this to solve triangles that are not right triangles. Okay, obviously if it was a right triangle, we could just use trigonometry to solve it. Okay, so there's only specific instances that you can use the law of sines. Okay, and those guys are right here. Okay, so if we're in a situation where we know two angle measures and one side length, we can use the law of sines. Okay, so that side length could be an included side between the two angles, so you would know an angle, an included side, and then an angle, or it could be a non-included side, so you could know an angle, and a non-included side. Okay, the important thing is that you know two angles and one side length. Okay, and this is a situation we're going to work with today. The other situation where it works is if you know two side lengths and a non-included angle. Okay, so it has to be side, and then a non-included angle. It can't be SAS. SAS, it won't work. Okay, it has to be side, non-included angle, and we'll deal with that tomorrow. So we're primarily going to work with this situation today. Okay. All right, so let's see what we have going on here. Okay, I need to solve this triangle, and notice that I have two angles and one side. Okay, I have an angle, and a non-included side. Okay, so that means the law of sines will work. Okay, so let's see. So if I take the sine of angle F, which is 40 degrees, and put it over the length of the side that's opposite angle F, so that would be GH, so this 10, that has to be equal to the sine of angle G, okay, which is 93 pesos, over the length of the side opposite that, so that would be FH right here. And then we get the sine of angle H over the length of the side opposite angle H would be FG. Okay, now right off the bat, I always start with the missing angle measure. Okay, so I know that this guy right here, okay, the measure of angle H, I can apply the triangle sum theorem to figure that out because I know the other two. So if we go 180 minus 40 minus 93, and then you just punch that into your calculator, I'm pretty sure you're going to get, let's see. All right, that would be 140 minus 93. We're getting 47 pesos. Okay, so we know this guy is 47 pesos. So that sine of angle H becomes a sine of 47 pesos. Okay, so we'll change that H to this 47. Okay, so notice really all I have left to do is I have to find these two missing side lengths. I have to find FH and I have to find FG. And this is the guy that's real important. Okay, the reason that this guy is important is notice that you know the numerator and the denominator of this ratio. Okay, over here we know the numerator, but we don't know the denominator. Here we know the numerator, but we don't know the denominator. So this guy is like your cornerstone ratio. Okay, so if we set this guy equal to that guy, it becomes a proportion, and we can solve it using cross products. And that'll give me a method for solving for FH. And then I can come back and I could take this guy and set it equal to that guy. And once again, I get a proportion, so I can solve it using cross products. So let's do this guy first. Okay, so I'm going to take my cornerstone ratio where I know everything. The sine of 40 pesos over 10, and set that equal to this guy. The sine of 93 pesos over FH. Okay, and then I take my cross products. Okay, so I can say FH times the sine of 40 equals 10 times the sine of 93. And then if I want to know what FH is, all I have to do is just divide both sides by the sine of 40 pesos. And I'm going to punch this entire thing into the calculator. Okay, so I've got 10 times the sine of 93 pesos, and I'm going to divide that by the sine of 40. Okay, all right, so we have to separate the numerator from the denominator, so you need those guys. And then when you punch in sine in your calculator, you'll get this guy show up, so I'll need a second one there. And same thing, when you punch in sine here, this guy will show up, so I'll need a second one there. And then obviously we're gonna have to round things off. Okay, so let's see, I go parenthesis, 10 times the sine of 93, and then two parentheses, divided by parenthesis, sine of 40 degrees, and then two parentheses, and hit enter. And it comes out to be, when I round things off, 15.54. Okay, so FH, okay, right here is 15.54 units, and we don't have a unit of measure, so it's just 15.54. Okay. All right, so now I have to go after this guy right here because I need to figure out what's this last side length, FG. So take my cornerstone ratio, this sine of 40 pesos over 10, and set that equal to this guy. Sine of 47 pesos over FG. And again, I have a proportion, so we use our cross product. So I go FG times the sine of 40 and that has to equal 10 times the sine of 47. Okay, and once again, I would have to divide both sides by the sine of 40. Okay, so I get FG equals 10 times the sine of 47 pesos, all divided by the sine of 40 pesos. And again, I'm going to punch that entire thing into my calculator, so I need to separate the numerator from the denominator. And we know when I punch in sine, in my calculator, it's going to give me that, so I need a second one. And down here, when I punch in sine, it's going to give me that parentheses, so I need a second one. And then I punch in. Okay, so we go parenthesis, 10 times the sine, and the parenthesis comes up, 47, so I need two parentheses, divided by parenthesis, sine, and the parenthesis comes up, so I punch in 40, and then two parentheses. And I round off to the nearest hundredth, so I get 11.38 when it's rounded off to the nearest hundredth. Okay, so this guy right here is 11.38 units. And it is solved. The triangle's solved. I have all three angle measures, and I have all three side lengths. Okay, easy enough. Okay, let's try this guy. Okay, let's see. I have two angles and an included side. Okay, the last one was 2 angles and a non-included side. This is 2 angles and an included side. The important thing is that I have 2 angles and 1 side length. Okay, so right off the bat, I would use the triangle sum theorem, okay, to find my missing side length. So we go 180 minus the 58 minus the 62, okay, right there. So 180 minus 58 minus 62, and I get 60 pesos. Okay, so I have the missing side length. So all I'm gonna have to do is find the 2 missing sides. Okay, so let's see. If we go the sine of angle A, which is 58 pesos, over the length of the side opposite angle A, which is BC, that has to be the sine of angle B, which is 60 pesos, over the length of the side opposite, which is AC, and we know AC is 23, equals the sine of angle C, which is 62 degrees, over the length of the side opposite angle C, and that's AB. Okay, so again, here's my cornerstone ratio. Okay, because I know the numerator and the denominator. So this is the guy I use to find BC and then AB. So let's find BC first. Okay, so first thing I do is I take my cornerstone ratio, sine of 60 pesos over 23, and I set it equal to sine of 58 pesos over BC. And I've got a proportion, so I use cross products. So I get BC times the sine of 60 equals 23 times the sine of 58. And then I divide both sides by the sine of 60 to get my BC. Okay, so let's see, I'm gonna have parenthesis 23 times the sine of 58, okay, and I'll need double parentheses there, all divided by the sine of 60, so I need parenthesis, sine of 60 pesos there, and I'll leave my parentheses in here, and then we just punch that in. Okay, so let's see, parenthesis 23 times the sine of 58, double parenthesis, divided by the sine, I'm sorry, let's go back, let's get a parenthesis there, parenthesis, okay, sine, and parenthesis comes up 60, double parenthesis. Okay, and I'm getting, when I round things off, 22.52. Okay, so my BC right here is 22.52. Okay, all right, so now I have to find my AB right here. Okay, so I take my cornerstone ratio, sine of 60 pesos over 23, and set that equal to this ratio, sine of 62 pesos over AB. And again, I have a proportion, so I use cross products. So I get AB times the sine of 60 pesos equals 23 times the sine of 62 pesos. And so I have to divide both sides by the sine of 60. Okay, so AB will be 23 times the sine of 62 pesos, all divided by the sine of 60. And then get your parentheses in there to separate the numerator from the denominator. And we know we're gonna have parentheses around our angle measures right there. And then we punch in and round off. So let's see, parenthesis 23 times the sine 62, double parenthesis, divided by parenthesis, sine of 60, double parenthesis. And I round off, and I am getting 23.45. Okay, so this guy right here, 23.45. Okay. All right, so that takes care of the first egg, okay, dealing with 2 angles and a non-included side, and then 2 angles and an included side. Okay, that wraps it up for today. You guys stay safe out there, and I miss you a whole bunch.